Hello YouTube viewers, welcome to this video. I am Venkat and this is Just Me an Open Source channel. Right, as you have probably noticed in the figlet here, the video I'm going to do today is about provisioning a Kubernetes cluster using Juju. So Juju, if you're not aware of it, it's like a package manager or an application deployment engine. You know about Helm, right? So in Kubernetes, within the Kubernetes cluster, you use Helm to deploy applications, right? So Helm is kind of a package manager where you deploy packages, where you deploy applications into your Kubernetes cluster. So Juju is something similar. It's from Canonical, the project, the company behind Ubuntu. So Canonical, they've developed Juju. So Juju is not just for Kubernetes, so any applications for packaging and building and deploying an application. So we can use Juju that takes care of all the underlying complexities and everything. So you basically write something called charm. So for Helm, you know about charts. So you define what your infrastructure has to be, your application has to be in charts with various configurations and deploy the Helm chart. So similar to that, in Juju terms, we have charm. So there is charm store, like in Helm, you have the Helm repository where you search for charts and you deploy that chart. For Juju, you've got charm store. So you search for applications in charm store and you can deploy it. So one such application is Kubernetes. So we are going to use Juju to install the Kubernetes charm. So the advantage of using Juju is you don't have to really worry about the high availability. The management of your Kubernetes cluster becomes very easy. So it's readily available, highly available. You can deploy multi-master, multi-etcd node. So previously in all my Kubernetes provisioning videos, I've used kubeadm. So basically what we've done is we used a master node where we have deployed all the master components along with the etcd, but we haven't actually set up any high available etcd cluster. So to start with, we need to have like 3 etcd nodes in a cluster. And using Juju, what we are going to do is we are going to deploy etcd as a separate cluster. We are not going to share the same machine as we are running the master components. So every single component will be running on its own machine. So when I say machine, I'm going to show you how to set up Juju and how to install Kubernetes on your local machine, right? So Juju also supports various cloud providers, so you can use Juju to set up Kubernetes cluster in AWS, Azure, GCP, and so on. But at the moment, I don't have access to all those clouds. In the future, I will show you how to use Juju to deploy cluster onto those cloud providers. But for now, I'm going to use a local host, which is a bare metal thing, physical server, not in any cloud. I'm going to show you how to do that. But bear in mind, everything has to be on its own virtual machine or own Linux containers. So when you're using Juju with a local host as the controller, what you're going to use for servers or LXC containers. So if you haven't watched my videos on LXC containers, I've done a video on that, getting started with LXC containers. So go and watch that video. So you need to have LXC installed, LXD installed. So this Juju Kubernetes will be provisioned on LXC containers. All right. So, all right. The other thing to note is I've got the machine that I've got now. It's not my laptop machine. My laptop, I've tried this on my laptop, but it worked okay, but it took a lot of resources. So my laptop, although it coped with it, it was quite a bit sluggish during the time I provisioned my cluster. It's going to deploy like 8 or 9 LXC containers, and it's going to take a hell of a lot of CPU, memory, and so on. So bearing in mind the number of machines we are going to deploy, the machine that I've got here has got 16 CPUs, and I've got like 32 gig of memory RAM. 32 gig RAM and 16 processors. So it's a pretty powerful machine. But if you're trying this on your laptop, it might suffer depending on how much system resources you've got. So if you're going to try this on a 2-core machine or a 4-core machine with 4 gig RAM or 8 gig RAM, it's not going to work. So you need to have a machine with bigger resources, probably a server. If you've got access to any server, you can try that one. All right. So to start with, my machine I've got here has got 16 CPU and 32 gig memory. It's more than enough for running Juju and to create your Kubernetes cluster. All right, so my machine is an Ubuntu 18.04 machine. The first thing you need to have is Snap. So we are going to install Juju first. We are going to install Juju using Snap. All right, for that you need to make sure that snapd is running. So I've got snapd running. If you're on an Ubuntu machine, snapd will always be there, will be installed. Or if you don't have it, sudo apt-get install snapd. So that will do it, and you have to enable and start the snapd service. Sudo systemctl enable -- now snapd. That will enable the snapd service as well as start the snapd service. All right, so once you have Snap installed, by the way, if you're following this on an other distributions unlike Ubuntu, if it's not a Debian distribution, you can still install snapd. It's supported for almost all Linux distributions. So find your package manager and search for snapd, install it, and enable the service. So you need to have Snap installed, and then we can install Juju. Sudo snap install Juju -- classic. So that's needed. So that's the command to have Juju installed on your machine. So you can do sudo snap search Juju. That's the one here, 2.6.9 version at the time of recording this video. Sudo snap list. So I've got Juju already installed, so I'm not going to do that one. All right, so LXC list. I'm also running LXD. Sudo systemctl status LXD. So LXD is running. Refer to my getting started with LXD video if you want to set up LXC. So the two important things are snapd and LXD. All right, so in addition to that, you also need to have a handful of resources. CPU, I would say if you've got like 8 CPU and 16 gig RAM, that should be sufficient. All right, so this is not a production use case because you're running everything on a single machine. This is for development, learning, or testing purpose. So yep, and the first command is Juju - Juju version. You can look at that version here. So I think I've got 2.6.9 version, and Juju help if you want to look at help for any of the commands. So Juju has got, I would say, the documentation is quite complete and very exhaustive, very extensive documentation. So for any single command, Juju help and the subcommand, let's say who am I, that will give you details about that subcommand. So you can read the entire thing about Juju just by looking at the Juju's man page. All right, so the first thing we got to do is Juju controller, Juju bootstrap the controller. So first we are going to bootstrap a controller node. Let me show you LXC list. At the moment I don't have any LXC containers. The first thing is to bootstrap a controller node. So controller node is the node that has all the configurations, and then it will schedule jobs to all the individual nodes where we are going to install our applications or the Kubernetes components. All right, so you will come to know better when I show you, when you watch this video completely. So Juju bootstrap localhost, because we are not using any cloud provider. But if you're using a cloud provider, you can use Juju bootstrap AWS or GCP and so on, which I'll come to in a later video. So for now, we are going to go with the localhost, Juju bootstrap localhost. Right, so that's creating an LXC container. If I do LXC list, and it has created our first container, LXC list waiting for address. So it's going to install a script, and it's going to configure our controller node. Right, so meanwhile we can look at Juju controllers. That gives you the localhost controller. We have two models here, Juju models, no API address. Okay, so let's wait for this to complete and then we can look at the models. All right, the command completed. So now we have the controller bootstrapped, and if I do lxc list, you can see that it's running. So that's our controller node, and you can do Juju controllers. So we have the localhost dash localhost, that's the controller. Juju models, and we have the model controller. So controller, so we define models for the individual applications that we deploy using Juju. And in the model controller, we have one machine, which is the controller machine, and it also created a default model. Either you can use this default model or we can create our own model. All right, so Juju Juju add model K8s. So that's going to add a new model. Model is just like a placeholder where you can deploy your application. It's like an environment. Juju models, and now you can see K8s, and if you see the asterisk, so that's the active model. We don't have any machines yet. So now we are good to deploy the Kubernetes. Like how we deploy Helm chart, we are going to deploy Juju charm for Kubernetes. So bear in mind, this is going to take a long time. If you're patient enough, you can sit here and watch for 30 or 45 minutes. I think it also depends on the speed of your processor, what resources you've got. So let's deploy that. The command is Juju deploy charmed Kubernetes. So that's going to deploy the Kubernetes cluster. It's going to bring up all sorts of machines, and it will configure the individual components, each cluster components and everything. So this will take about 30 to 45 minutes, and then we can look at our Kubernetes cluster and what resources it has actually deployed. All right, so that's doing it. And meanwhile, if you do lxc list, it's still not doing. So now it's adding the machines here one by one. And you can look at the Juju status command, Juju status. So you can see here there are 3 machines at the moment. So let's wait for this to complete. But it's going to take 30 to 40 minutes. But I'm just waiting for all the machines to get provisioned. And then I can show you the list of machines and what it's going to do. 5, 6, 7, 8th machine. So I think one more machine, 2, 3 worker nodes. Yeah. So we have 9 machines here. Deploy of bundle completed. All right. So let me close this and show it in one window here. All right. LXC list. So now you can see here it's provisioning the LXC containers. Juju status. You can see here the machines are being provisioned at the moment. So running, so 4 machines are running. That's what you see when you do LXC list. So now it has gone for more machines. Juju status. All right, so running, so 3 more machines to go, and all the applications or all the components here, you can see it here. And under the message section, you can see what it's actually doing at this point in time. So now it says it's waiting for the machine. Now let's look at what are all the components that it's going to deploy. What are all the machines it's going to deploy. So easy RSA, so that's for the certificate authority. So we have got a separate LXC container, LXC machine for certificate authority. So that's the machine that's responsible for generating the certificates that we are going to use for all the components in our Kubernetes cluster. We have 3 etcd nodes running on 3 different machines, not on the same machine. So that's a highly available etcd cluster. And we have the Kube API load balancer. That's required because our Kubernetes master is a multi-master, right? It's a highly available multi-master control plane. So we can't access the master directly. So we need to have a load balancer that load balances between the 2 masters. The API servers that are running in these 2 masters will be load balanced by this load balancer. And then we have 2 K-masters, 2 master machines, and we have 3 worker nodes. Let's see where we are now. Juju status. All right, so agent is executing. What it's doing is it's bringing up the LXC containers, and it will install a Juju agent. So the agent is the one that's responsible to configure or install anything on the machine itself. So the controller machine deploys the agent. Controller machine schedules what needs to be done, schedules the actions that needs to be run on these individual machines. So if you look at the app here, there is this containerd, ECRSA, etcd, flannel, load balancer, Kubernetes master, Kubernetes worker. All right. So it has started all the machine and now it's doing something. And you can sit here for like 30 minutes and watching what it's actually doing. It's very interesting to watch because every single time you get an update here, what it's actually doing. So when you're doing this for the first time, I would advise you to watch what's going on, so you get a better understanding of how the flow is. All right, let's look at Juju Status. All right, so you can see active and it's blocked, missing relation to certificate authority. By the end of 30 minutes or 40 minutes, you will see everything is active. So at this point, it's now the Kubernetes cluster is evolving. So one by one, each of the components are getting installed. And for all these units here, you can see installing the Charm software. And then we will be able to have our cluster up and running in about 30 minutes. All right, Juju Status. All right, so what I'm going to do is I'm going to run a while loop to see what it's doing. So while true, do Juju Status. I'm going to sleep for like 15 seconds. Let me change that to 10 seconds. Sleep for 10 seconds and then run Juju Status again. Right, so now I can sit here and watch. It gets updated every 10 seconds. So this one is active, ECRSA, so that's the certificate authority. Certificate authority is ready. etcd, missing relation, leader setting changed, installing Nginx. So basically you can see what it's actually doing. It will be very, very helpful. You could see the public IP address of all the LXC containers, the versions of the app that we are installing, and that's the machine ID 0, 1 through to 9. So we've got like 10 machines. So 1 for certificate authority, 3 for etcd cluster, that's 4, 1 for load balancer, that's 5, and 2 master nodes and 3 worker nodes. So in total we have deployed 10 LXC containers. So that's a truly highly available machine, except that it's running on my single server. So it's not truly highly available, but you know what I'm saying, right? So I'm going to pause the video here and I'm going to come back in about 30 minutes when all these components are deployed, all right? All right, so welcome back, and I think everything is completed now. So you can see the workloads, all of them are active and all the apps are active as well. So we can close this. Bring it to foreground, control C. All right, so Juju Status. So we have everything running and Juju machines. So that will show you the list of machines that we've got, all the LXC containers. And if you want to look at any specific machine, so Juju show machine, for example, these are the machine ID 0, 1, 2, 3, 4, 5. So for example, if you want to look at the ECRSA one or the etcd machine, which is 1, 2, and 3, I can say Juju show machine 1. So that's the excuse me. So that's the etcd1 machine, and you can see the IP address and the machines, the hardware core. So it has got 0 core, 0 memory. Maybe I think it's the one that's currently using it. Juju show machine 8, that's one of the worker node. All right, so here you can see all the worker nodes by default will get 4 CPU, 4 gig of memory. Although this is configurable, when you want to add a new worker node, we can configure it, or you can set the constraints. So it is Juju set constraints for Kubernetes worker, I think. So you've got the help command, Juju set constraints help, and you will have the documentation for that. Constraints help, application help not found. Juju set constraints minus help, is it? Yep, get constraint, set constraint, MySQL. So in this case, Juju set constraints, whatever the unit is, and then memory, cores, whatever you want, you can look at the help documentation to configure it. So for now, we have our Kubernetes cluster running. So we have 2 master, 3 worker nodes, 3 etcd nodes, certificate authority, load balancer, everything running on its own LXC containers. All right. So Juju machines, we saw that. Just to show you list of machines. Juju models, so which model we are currently connected to. So we are connected to the K8s model, and in K8s model we have 10 machines, total 16 cores, number of units is 20, and the user is admin. So Juju, who am I? So I'm the user admin, right? So Juju controllers, list the controllers that we've got. So we are using the localhost controller, and the model controller, we have 1 machine, which is the controller machine itself. All right, so we have got the cluster now. How to access the cluster? So you need to have kubectl installed on your local machine. So I have kubectl installed under user local bin kubectl. So in order to access this cluster, we need to copy the Kubernetes configuration file, the kubeconfig file, to our local machine. So we need to Juju Status. So we need to connect to one of these LXC containers, Kubernetes master 0 or Kubernetes master 1, and download the Kubernetes config file to our local machine. Then we should be able to connect to the Kubernetes cluster. All right. So there is a Juju command for copying files between your host machine and the LXC containers that you have deployed. So the command is Juju SAP and the machine name Kubernetes master /0 or 1, whatever it is, and in there it will be the config file in the home directory itself. So copy that to your home directory .kube, and the file name is config. All right, so that's configured, that's copied, ls kube. So we have this config file here. So now we should be able to access the Kubernetes cluster. Right, so kubectl version -- short. All right, so we are running version 1.16. So it has provided us with version 1.16. Kubectl cluster info, and it has deployed metric server, Grafana, InfluxDB, core DNS, Heapster. I don't know why it has deployed Heapster, because we'll be using metric server anyway. Kubectl top nodes. All right, so that's the CPU and memory utilization from the metric server. Kubectl get nodes. So it's only showing you the worker nodes, so you won't be able to see the master nodes. Kubectl get nodes -o wide. All right, that's running fine. Let's deploy a sample application. Kubectl create deploy Nginx -- image Nginx. That's deployed. Kubectl get all. All right, so container is getting created. Let's see what namespaces we've got. Kubectl get namespace, ingress Nginx. It also comes with ingress controller. Kubectl get ingress. So there is no ingress, but you can define the ingress. Kubectl -n ingress Nginx Kubernetes worker get all. So there are Nginx ingress controllers running on all of the worker nodes. So we should be able to use, if you want to use Nginx ingress controller, it's already installed. We'll let you know. Juju Status. All right, so everything is working perfectly fine. Kubectl get all. Right, our Nginx pod is also running. Kubectl delete deploy Nginx. Kubectl get all. So we have 2 master nodes, multi-master with a load balancer on the top. It's a multi-master, highly available Kubernetes cluster with etcd running as a cluster on individual nodes on its own Linux containers. All right, so one other thing I wanted to show you is, so you've got your cluster here. So how about if you want to add a worker node or add your master node, add an extra master node? It's called Juju scaling. So let's check the documentation for that. Juju Kubernetes scaling. Scaling charmed Kubernetes documentation. So if you want to scale, the command is juju add unit. So here, if I do juju status, you will see the list of units here. So each of them is a unit, so you can add additional units to it. Right, so juju add unit Kubernetes master, juju add unit Kubernetes master minus n3. If you want to add 3 more masters, you can add minus n3. This is what I was talking about. If you want to set the constraints, you can set the constraint. Juju set constraints Kubernetes workers. If you don't want to give 4 cores and 4 gig of memory, if you want to change that, you can change that by setting the constraints. So any new units that you add will have 2 cores and 6 gig if you run this command. Scaling down the Kubernetes worker. So it's again same, so you need to drain your Kubernetes cluster and then do juju remove unit, whatever unit you want. All right, so HCD, everything is quite simple. Let's try that out. Juju status. So the unit we are interested in is Kubernetes-worker. So that's the unit. And if you want to add an extra master node, you can add Kubernetes master. So the command now is juju add unit Kubernetes worker. All right. So now, again, it's going to take like 10 or 15 minutes. I'm going to pause the video and come back when it's ready. By the time it's ready, you will be seeing another node here. So at the moment we have scale 3. We have 3 Kubernetes worker. And now you should be able to see more. Juju status. Yep. And you can see here there is another LXC container that got started and the status is waiting. So now we can see 3 of 4 is available. So the total is 4 and now it's allocating, waiting for the machine. Once the machine comes up, the Juju agent on that machine will configure that machine as a Kubernetes worker node and it will create the flannel subnet for it and everything will be ready in about 10 to 15 minutes. All right. So that's how you add an additional Kubernetes worker. If you want to remove it, juju remove unit Kubernetes worker / whichever you want. If you want to remove 8, for example, so this one is a Kubernetes worker node. This one is also a worker node. So you can say 7. So that will remove that Kubernetes worker node, which is an LXC container. And make sure to drain that worker node. If you've got any pods running, make sure to drain the pods. All the pods are gone, and then make sure to remove that unit. All right, so that's how you remove an unit. Similarly, you can add juju add unit HCD or add unit Kubernetes master. So that's how you scale it basically. All right, let's check the status. Juju status maintenance. So the machine LXC container is started and it's installing the charm software, and then it will install the container runtime, and then it will set up the flannel subnet, and then we should be good to go. So then we will have like 4 Kubernetes worker nodes. All right, so let me pause the video and come back when it's ready. All right, the command completed, and now we have 4 Kubernetes worker nodes, 2 master nodes, 1 load balancer, and so on. So that's how easy and simple it is to add a new worker node or a new master node or an HCD node and so on. So similarly, you can take a worker node down, scale up. It's very easy. It's that simple. But unfortunately, it takes a little longer. It took me about nearly 15 minutes to complete, just to add 1 extra worker node. So, but it's just a single command to add an extra worker node. You don't have to fiddle with a Linux virtual machine or LXC container and do everything yourself, copy the certificates, installing kubelet and configuring it and so on. So everything will be taken care by Juju. So all you need to do is run juju add unit Kubernetes worker. That will add an extra worker node in your cluster. All right, so that's there. And now if you want to completely destroy this or delete this cluster, Kubernetes cluster, the command is juju delete model, or I think it's juju destroy model or something. Okay, let's try that. Juju models. So we have the K8s model we deployed with 11 machines, 20 cores, 23 units. All right, so if we delete this model, all the machines that we deployed, that got deployed under this model will get deleted automatically. So all we need to do is Juju destroy model K8s, that's it. Asking for the confirmation, why, that's it, destroying model. It will delete all the LXC containers one by one. And then we can destroy the controller itself. So we've deployed the localhost. We bootstrapped the localhost controller. We can delete that controller as well. And if you want to follow this on an AWS or GCP or Azure cloud, everything that I shown in this video will be applicable to cloud. The only thing is, initially when we did bootstrap, Juju bootstrap localhost. So that's the command we did for bootstrapping a controller in localhost. But instead, what you can do is Juju bootstrap AWS and so on. So there is a command, Juju command not found. So let me log into my machine. Let me log into my server. Okay, so let me show you what clouds are supported. Juju list clouds. So AWS, Azure, Google, Oracle, Rackspace, the localhost, that's the one that we used. So it's using LXD container hypervisor, but you can use AWS and Juju bootstrap AWS. So it's going to ask you for your secret key, access key ID, and so on. But if you have AWS CLI configured in your machine, you can ask Juju to load the credentials from the credentials file that you used for your AWS or EB CLI or so on. So I think the command is Juju auto load config or something. Juju help less and search for credentials. Yep, there it is, auto load credentials. So that will attempt to load the credentials that you've got in your file system. For AWS, I think it's .aws directory. Under .aws, there's a credentials file. So that will get used and so on. And if you can also do Juju bootstrap, Juju help bootstrap, Juju help bootstrap, and you will have all the details here. So that's the command that I'm looking for. Juju bootstrap AWS. It will ask you for the region where you want to deploy, or you can pass that as an option as well. Juju bootstrap AWS US East 1 and so on. And once you have the bootstrap ready, it will deploy an EC2 instance in your AWS account as a bootstrap, as a controller. And from then you can follow my video, basically Juju add model and then Juju deploy charmed Kubernetes. So that will deploy. So in my case, it has deployed like 9 LXC containers. But if you use AWS, it will create 9 EC2 instances in your AWS account. All right, so model destroyed, Juju models. So that model, K8s model, is gone. Juju machines. We don't have any machine because we are now connected to the K8s model, which we just deleted, so it won't be there. Juju controllers. So we need to delete this localhost controller that we created. Juju destroy controller localhost dash localhost. Yes. So that will destroy the controller. Cleaning up the controller machines, waiting for hosted model. Okay, that should be it. Juju list, Juju models. Nope. Juju, you need to have a controller to be able to interact with Juju commands. All right, so that's it. I think I've covered all I wanted to cover in this video. So it has got lots of moving parts, lots of things. Basically, you need to have snapd installed, and then you need to have LXD installed, then you are good to go. But bear in mind, it requires lots of resources. So if you're trying this out on your laptop, it will make your laptop very sluggish, so you won't be able to use your laptop if you've got a very low-end system resources on your laptop. Like if you've got 2 CPU and 4 gig of RAM, and if you follow this video, it will completely stall your laptop and then you have to reboot your laptop. So make sure to follow this demo on a powerful machine that has got at least 8 processor, or at least 4 processor will be okay, but RAM, you need to have like 16 gig of RAM. Yep. Please try this. If you've got any questions or feedback or issues, leave me a comment. As usual, please share and subscribe. I will see you all in my next video. Bye bye.